Hey dear students, hope you are doing well. Today we are going to discuss about SLO number 1.3.1, which is related to calculation of percentage of element in a compound and of water of crystallization and hydrated salt. So first of all, I'm going to explain the first part, that is percentage of element in a compound. As we know that the compound is made up of the combination of different type of atom with a fixed ratio, like we have H2O. In H2O, we have two hydrogen and one oxygen, so their ratio is fixed. Always we have 2:1 ratio for hydrogen and oxygen in water. When we talk about the percentage calculation of element in a particular compound, we have to focus that element, and we have to take a ratio for that element in whole compound. What is the formula? I'm just going to show you. The formula for percentage of element in a compound is, you have to write the mass of element first, and you have to divide it with the total mass of compound, and then that ratio is going to be multiplied by 100 because it is percentage. So here is one example in which they have asked that what is the percentage of nitrogen in urea. If we talk about urea, so the formula of urea is written in this form. The central one is carbonyl, and the two sides are having NH2 directly attached to carbon, right? In this, if we look for the nitrogen atom, so I can clearly see there are two nitrogen atom, one nitrogen on each side of carbon. So we can say there are two nitrogen atoms. As we know that the mass of nitrogen is 14 and there are two nitrogen, so the mass of two nitrogen in this compound is 28. So to calculate the percentage, I must have the mass of element on the upper side. So I'm going to write 28 over here, divided by mass of compound. Now for mass of compound, I have to calculate the whole sole molecular mass of whole compound so that I can keep it in denominator. For the mass of whole compound, I can have an idea that there are two NH2, one carbon and one oxygen. So I'm going to calculate in my own style. You can calculate by your ease, जैसे आपको easy लगता है. Is 60. It is 60 gram, right? You can also calculate for surety from calculator. It is 60 gram. So if we have 28 on upper side and we have 60 in denominator, so we have to calculate the percentage for that particular element, nitrogen. If you will solve it, you would have 28 divided by 60 multiplied by 100. You would have 46.66% as the answer. What does it represent? It represents that कि इस पूरे compound के अंदर जो नाइट्रोजन की contribution है by mass, it is 46. यानी कि 100% में से 46% जो mass compound का है वो किसकी वजह से है? वो नाइट्रोजन की वजह से. Now we are moving towards the next part of SLO. The next part of SLO is for water of crystallization in hydrated salt. Now, how come we understand the water of crystallization? In easy way, we have to recall the concept of alum. We have this as one type of salt and this as another type of salt. So in दोनों salts के क्रिस्टल्स को आपस में मिक्स करके डबल सोल्ट बनाने के लिए कुछ वाटर मॉलिक्यूल्स कंट्रीब्यूट करते हैं. एज यू कैन सी द स्काई पार्ट ओवर हियर, दैट स्काई पार्ट आई हैव रिप्रेजेंटेड एज अ वाटर मॉलिक्यूल. ये डबल सॉल्ट के अंदर भी ऑब्जर्व हो सकता है या फिर किसी सिंगल सॉल्ट के अंदर भी ऑब्जर्व हो सकता है, जिसे हम कहते हैं हाइड्रेटेड सॉल्ट. लाइक वी कैन टेक एग्जांपल ऑफ ऑक्सैलिक एसिड. ऑक्सैलिक एसिड के अंदर दो वाटर ऑफ क्रिस्टलाइजेशन होता है. व्हाट इज द पर्पस ऑफ वाटर ऑफ क्रिस्टलाइजेशन? ये किसी भी सॉल्ट की जो फिजिकल फॉर्म होती है उस फॉर्म को मेंटेन करने के लिए, क्रिस्टलाइन स्ट्रक्चर को मेंटेन करने के लिए हेल्प करता है. So here is the formula of oxalic acid. In oxalic acid, what we have, COOH connected with COOH, and there are two H2O. These are known as water of crystallization. That means this oxalic acid is hydrated. And in any hydrated salt, if we have water of crystallization, so we can easily calculate the water of crystallization in that salt by the same formula that we have used. For percentage of water of crystallization of salt, what we have to do, we have to keep the mass of water of crystallization in numerator and the mass of hydrated salt, whole salt, including the water of crystallization in denominator, and we would multiply it by 100. So let us calculate how many water of crystallization are there. As you know that is 2H2O and one hydrogen, one water molecule is 18 mu. So I'm just going to multiply that 18 by 2 because how many water of crystallization are there? There are two water of crystallization. So 2 into 18 would give you 36, right? So I'm going to write 36 in numerator and I would divide it by the whole mass of oxalic acid. Now, what is the total mass of oxalic acid? How come we know? We have to calculate by the traditional method of calculating formula mass and molecular mass. So I'm going to use it again. How many carbon are there? There are two carbons, so I'm going to multiply 12 by 2. How many oxygen are there? 2 plus 2, 4. So I'm going to multiply 16 by 4 because mass of oxygen is 16. How many hydrogen are there? There are two hydrogen, so I'm going to multiply 1 by 2, right? And what we have to add here more, there are two water of crystallization and we are already aware of it कि इन दोनों water of crystallization का mass 36 है. So I'm just going to add 36 over here, right? Okay, so we have the formula mass of oxalic acid 126. If you want to calculate it by yourself, you can calculate it. It would be 126 gram atomic mass for one molecule of oxalic acid. Now it is very easy. What you have to do for percentage calculation, you have to keep 126 in denominator and you have to multiply it by 100. Why? Because we are going to calculate percent. Cent means out of 100. So we are going to calculate percentage of water of crystallization in salt. So 36 divided by 126 is 0.28. I must multiply it by 100. So the water of crystallization base over here is 28.5. 28.5% is the contribution of water of crystallization in that particular salt of what? Oxalic acid. Hope you have enjoyed the video. If you have any question related to it, you can ask me. Thank you for joining. Lafis.